Hello everyone, how are you all? I am Siddharth Kumar Jha and I welcome you in the Digital Image Processing lecture series. So, in the last video, we have introduced the idea of sampling and quantization, the two main steps that convert real world images into the digital image. But today we are going to deep dive into the basic concepts behind them, including resolution, aliasing, and how the choice of sampling and quantization level directly affects image quality. So let's get started. So for detailed explanation, I have to go to my notepad. So just hold a second. Okay, so just do a quick recap, like what I have told you about the sampling. So sampling is like the dividing the image into discrete pixels or your spatial resolution you can say. Okay. And what I have told about you, the quantization. Yeah, quantization is nothing but the mapping pixel intensities into the discrete gray level or you can say intensity resolution. Okay. So I hope you have remembered these things. So let's get start with the spatial resolution. Okay. So spatial resolution. So spatial resolution is nothing but your sampling. So the number of pixels used to represent the image. Number of pixels used to represent the image is called your sampling. And we have also know like higher sampling. If there is higher sampling, so it means there is more details. And if there is lower sampling, means blocky or blurred image you can say. Okay. So suppose you have a photo at 1024 into 1024 pixels versus 128 into 128 pixels. So tell me, who has the more details? Obviously, because the pixel size is greater than in this photo, so its details and its resolution is high. Obvious, no? So this is all about your spatial resolution or your sampling. So let's move further, which is your gray label resolution, which is your quantization. So gray label resolution, which is your quantization. So it means the number of the number of intensity intensity level used to represent brightness. Okay. So it is like the determined by the bit per pixel, which is your BBP. So the formula is like L is equal to 2 to the power K. Okay. So here, uh, this is the formula for the quantization. As I have told you, like if there is K value is 2. So how many layers are there? 4 layers. And if there is the K value is 1. So how many layers are there? Obviously, bro, how many? 2 layers, which is called as the binary image. I have told you in the previous one. And if their K value is 8, so how much the value should be? So 28. वन दो दूनी चार दूनी आठ दूनी 16 32 दूनी 64 दूनी 128 दूनी 256. So 256. Okay. So what it is? It is nothing but your uh, gray level image. Okay, na? Okay. So let's move further. So if there is one bit is equal to two label, which is nothing but your black and white. Okay. And if there is 8 bit 256 label, okay, which is your standard grayscale, and there is 24 bit, which is around 16.7 billion, sorry, million labels. That means your RGB image. Okay, I hope I am clear. So let's understand the trade-off between the resolution and the storage. Okay, so let me write it down. Trade-off between resolution and storage. Okay, so here if the more pixels, or you can say the sampling, the higher spatial details. Okay, so more gray label quantization, which is your smoother intensity details, but both requires for the memory and the bandwidth. Okay, so let's take an example. Suppose there is a image like 512 into 512 pixels, so with a 8-bit pixel. Okay, so how many bytes are there? If you will calculate this, so you will get like 262,144. Okay, so what it means? It means almost your 256 KB. So this is how you can store a 512 into 512 image. Okay, so it requires almost 256 KB in your like in your device or in your memory. Okay, so this is how you can calculate. So if the same image at the 24-bit pixels, okay, so if it is same at for the 24-bit, so how many storage it will take? Correct? So 786 KB. How? Tell me how? Yeah, when it is about the 8 pixels, then how much it was taking? 512 into 512. Now it is 24 bits. 24 bits means what? 2 to the power 24 into 2 to the power 24, which is almost around 786. So just calculate it. So you will get the this value. Okay. So let's moving further. So now we will talk about the aliasing and your sampling. Aliasing in sampling. So what it is? So it occurs when sampling frequency is too low. Okay. So let me write it down. It occurs when sampling frequency is too low. Okay. So next it cause distort pattern that were not present in the original image. Okay. So it cause distorted pattern that were not present in original image. Okay, so I hope I am clear. So let's take an example. So you can say like Moir pattern in strip shirts on TV. Okay, so let me write it down. So example is like Moir pattern. in stripped shot on TV. Okay, so what are the solution for this? So the sampling theorem, which sampling theorem? Nyquist. Okay, so its solution is your Nyquist. Just hold a second. Nyquist sampling theorem. So what it say basically, it says like fs value is should be greater than equal to 2 of f of max. Okay, so it the value of f of s should be greater than or equal to the twice of f maximum. Okay, so let's move further with the quantization error. Okay, so let me write it down. The quantization error. Quantization error. So when it occurs, so it occurs when continuous gray level are mapped to fewer levels and result in loss of fine intensity details called the quantization noise. Okay. For example, a smooth gradient appearing as visual steps. Okay. So let's move further. Uh, let me write it down for you. So it occurs when continuous continuous gray level are mapped to fewer levels and the result in loss of fine intensity details, or which you can call as quantization noise. Okay, so example I have told a smooth gradient like appearing as your visible steps. Okay, so which is called as the posterization. Okay, so let's move further. The importance of these all things in the DIP. Okay, so it choosing a proper sampling and quantization is crucial for avoiding distortion, preserving the important image details, and optimizing storage versus quality. So let's uh, do a quick takeaway from this today's video. So in this we have understand like the spatial resolution depends on sampling, which is nothing but your number of pixels, and gray level resolution depends on the quantization, which is nothing but your number of intensity levels. Okay, and aliasing happens due to undersampling. Okay, and the quantization error happen due to the limited intensity levels, and balance is needed so that we are using the higher quality requires for more storage. I hope this is clear. So that's about the today's video. In this we have understand the sampling and quantization, the balance between the pixel resolution, gray label resolution, and storage requirement. So in the next video we shall explore how digital images are represented in memory, which will help you to understand the format and the data structure used in the image processing. So if you are learning something new in the video series, don't forget to subscribe and share it with your friends. So see you in the next video. Tab tak ke liye keep learning and keep exploring. Bye bye.